Science Olympiad Class 7. Motion and Time.
Imagine that you are traveling in a moving train. There are many other passengers in your compartment. Is there any change in your position with respect to another passenger sitting by your side, even though you are moving with the train? Look at the nearby trees, lampposts, houses, people, and animals outside. It looks as if the trees, houses, and lampposts are passing by you at a great speed. But houses and trees do not move. It is actually you who is moving with the moving train. Types of motion. Everything in the physical world is in motion, from the elementary particles within atoms to the largest galaxies of stars. These motions can be translatory, rotational, or vibrational motion, as shown in the following animation. Translatory motion. Translatory motion is that in which all the particles of a body move through the same distance in the same time. When a body moves along a straight line, it is called rectilinear motion. When a body moves along a curved line, it is called curvilinear motion. Rotatory motion. Rotatory motion is that in which a body moves about a fixed axis without changing its position. Examples are windmill, fan, spinning wheel, etc. Oscillatory motion. Oscillatory motion is that in which a body moves to and fro about its mean position. The motion of a swing and the pendulum of a clock show oscillatory motion. The leaves and branches of the plant also show to and fro movement under the influence of the wind. Periodic motion. Periodic motion is that which repeats itself after regular intervals of time. The motion of the earth around the sun, the motion of a clock pendulum, heartbeat, pulse movement are a few examples of periodic motion. Non-periodic motion. In case of a non-periodic motion, the motion does not repeat itself after regular intervals of time. Examples of non-periodic motion are blinking of eyes, occurrence of earthquakes, playing a football on the ground, moving a car on the road, and occurrence of a landslide. Repetitive motion. Movement of lips while speaking, flickering of eyelids, the fingers of a person playing a guitar, violin or harmonium are some examples of repetitive motion. All periodic motions are repetition, but all repetitive motions are not periodic. Speed. An object is said to be moving when it is changing its position continuously with respect to its surrounding objects. Suppose we observe the motion of a car and a bicycle on the road. It is noted that during the same time interval, the car is able to go much farther than the bicycle. This amounts to saying that the car moves faster than the bicycle. Thus, the distances covered by different objects in a given time, generally taken as 1 second, can be used to compare their motions. Speed quantity. In general, the physical quantity that measures the distance traveled per unit time is called speed. Thus, the distance covered in 1 second gives us an idea as to how fast the car is moving as compared to that of the bicycle. Speed is equal to distance covered by time taken. The standard unit of distance is meters, and that of time is seconds. The SI unit of speed is meters bar second. For average speed, the formula is average speed is equal to total distance covered divided by total time taken. Uniform speed. A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time, however small the time intervals may be. Suppose a car runs at a speed of 36 kilometers per hour. The speed of the car will be uniform only if it covers 18 kilometers every half hour, 9 kilometers every 15 minutes, 3 kilometers every 5 minutes, 300 meters every 30 seconds, 1 meter every tenth of a second, and so on. Thus, the car has uniform speed only if it covers equal distance in the smallest possible equal intervals of time. Variable speed. A body is said to be moving with variable speed if it covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, however small the time intervals may be. Scalar and vector quantities. Scalar quantities are those physical quantities which possess the magnitude only, for example, mass, length, and speed, etc. Vector quantities are those physical quantities which possess the magnitude as well as the direction, for example, weight, force, velocity, momentum, etc. Velocity. The velocity of a moving body is the rate of change of position of the body with time in a particular direction. Uniform velocity. A body is said to be moving with uniform velocity when it moves without change in direction and covers equal distances in equal intervals of time, however small the time intervals may be. A body moving along a straight line with uniform speed is an example of a body having uniform velocity. Variable velocity. Since velocity has both magnitude and direction, it is said to be variable if either its speed is changing or its direction of motion is changing, or both its speed and direction are changing. The velocity of a body moving along a circular track and covering equal distances in equal intervals of time is variable as the direction of motion of the body changes at each point of its track, though the speed of the body does not change. The velocity of a body moving along any curved path and covering unequal distances in equal intervals of time is variable as both the speed and direction of motion of the body are changing. Unit of velocity are the same as that of speed. Acceleration due to gravity. The velocity of a freely falling body under the influence of gravitational forces increases at a constant rate. It is said to accelerate. This acceleration is known as acceleration due to gravity and is usually denoted by the symbol g. The value of g has been found experimentally to be 9.8 meter per second squared. The acceleration of a freely falling body under the influence of the force due to gravity is called acceleration due to gravity.